When you're coding in Python, how you organize your information, well, it's pretty much everything. So today, we're diving into two of the most powerful and useful tools you have for doing just that: dictionaries and sets. These are absolutely essential for managing your data in a way that's clean, fast, and makes a whole lot of sense. So let's explore how they work and why they're so key to writing great Python code.
To really get why these data structures are so important, let's start with a practical challenge. Let's say you're building a Scrabble app. Now, you need a way to look up the point value for any letter, and you need it to be instant. How would you store that information so your app doesn't lag and feels super responsive?
Well, the perfect tool for this job is a Python dictionary. As you can see right here, each letter, like A, B, or Q, acts as a key, and it's paired directly with its point value, which we call, you guessed it, the value. So A points to 1, B points to 3, and so on. This direct link is really the whole idea behind a dictionary.
So, what is a dictionary, technically? Well, it's a mutable collection, which just means you can change it after you've created it. And it stores data in these key-value pairs. Now, here's the important part. The keys have to be unique. You can't have two A's, for example. And they have to be immutable. And immutable just means it can't be changed. That's why things like strings and numbers make great keys, but something like a list, which you can change, just won't work.
The real magic of a dictionary is how you get data back out of it. It's so incredibly direct. If you want the score for the letter P, you just ask the dictionary for the key P, and bam, it immediately gives you back the value. There's no searching, no scanning through a list. It's a direct, instant lookup. Now you might be thinking, hold on, couldn't I just do the same thing with two separate lists? You know, one list with all the letters and a second one with all the scores, just make sure they're in the same order. And you know what? That is a totally fair question, and it actually sets us up for a really cool performance showdown. Let's just break down the logic here. With a dictionary, it's a single step. Give me the value for this key. Simple. With two lists, it's a whole two-step process. First, you have to search all the way through that letters list to find the position, the index of the letter you want. Then, you use that index to go get the score from the other list. You can already feel how it's a bit more work.
A little extra complexity might not seem like a big deal, right? But what happens when we scale this up? I mean, really scale it up. Let's pretend our app is super popular and we need to do 6 million score lookups. We're going to time both methods and see which one really is faster. So here's the code for the list approach. The really important thing to see here is this line, letters.indexOfQuery. What that means is for every single one of those 6 million lookups, the code has to do a search, probably starting from the beginning of the list every single time. That is a lot of work. And the result of all that searching, it took 2.219 seconds to finish all 6 million queries. Okay, remember that number, 2.219 seconds.
Okay, now let's look at the dictionary method. Just look at how much simpler this code is. Inside the loop, it's just a direct lookup, Scrabble score of a query. No searching, no index method, nothing like that. It uses the letter itself to go straight to the score. And the time it took the dictionary to do the exact same 6 million queries? Just 0.589 seconds. I mean, the difference is just staggering. So what's the bottom line here? Just by choosing the right data structure for the job, we got almost a 4x speed up. For any app where performance is even a little bit important, this is a massive, massive win. This is exactly why knowing your dictionaries is so crucial. Okay, so dictionaries are amazing for those key value pairs, but programming throws all kinds of other challenges at us. What if you don't need to pair data up? What if you just need a big collection of items, but, and this is the important rule, you can have absolutely no duplicates? For that job, we turn to Python's other power structure, the set. A set is also mutable, but it's an unordered collection. Its number one defining feature is that it only stores unique items. And just like our dictionary keys, the items you put in a set have to be immutable, things you can't change. This slide shows off a set's superpower perfectly. If you take a string like abracadabra and you just turn it into a set, all those extra A's and B's and R's, they just vanish. You're left with just the 5 unique letters that were in the original string. Sets do all the work of getting rid of duplicates for you, automatically. Now here's a fascinating little quirk you should know about sets. Because of how Python works way down deep inside, a set actually treats the number 1 and the Boolean value true as the exact same thing. And it's the same story for 0 and false.
So if you try to put both the number 1 and true into a set, you'll only end up with one of them. Kind of weird, right?
But sets are way more than just duplicate killers. They come with these super powerful built-in operations that are based on mathematical set theory. You can find the union, which mashes two sets together. You can find the intersection, which tells you what they have in common. And you can find the difference, which finds what's in one set but not the other. For example, you could use a difference operation to instantly find out which students in your class are not also in the school band.
So, with all these different options, how do you choose the right one? Well, think of this table as your ultimate cheat sheet. Do you care about the order of your items? If yes, you need a list or a tuple. Can the data be changed later? That's what decides between a list and a tuple. If you don't care about order, but you need those key value pairs, a dictionary is your best friend. And if you just need a fast way to store unique items and order doesn't matter, a set is absolutely the way to go.
So we've seen it. We've seen how dictionaries give you lightning-fast lookups and how sets just effortlessly handle unique items. These aren't just abstract ideas from a textbook. They are real, powerful tools designed to solve real-world problems elegantly and efficiently. So now the only question left is, what problem are you going to go solve with them?